This is Bob. He is a materials scientist in the field of indentation. Especially he loves the nanoscaled experiments. He is performing some tests at this very moment.
Hey, you're probably wondering what I'm doing here. Prepare for impact. Wow, I'm even flatter than before.
Now he needs to check the data to see if the experiment was recorded properly.
Oh man, not again. Wheelless data points.
Bob's problem is very common in the field of high-speed deformation mechanics. The deformation velocity or strain rate can be up to 1,000 per second. Only a sampling rate above this value can also resolve the force to depth curve right. Also important is the synchronization of all measurements to the time. This ensures correct evaluations of hardness depending on strain rate. Looks like Bob is trying a load step experiment next, another method to achieve high strain rates. With the tip already in contact, just a little bump needs to be brought up.
Just let me get this hammer up here. It's so heavy.
Just don't tip over Bob.
Smash! Oh my God, I'm so sorry. This rarely happens.
Unfortunately, Bob is not right. Dynamic contributions of the whole device can influence the experiment. The data must be filtered and corrected afterwards, if even possible. In his last testing method, Bob uses a constant strain rate. This means that the load is increasing with displacement and time.
This is so much easier. I have time for a coffee break.
2 hours later.
In this case, easier doesn't mean better. Very high strain rates can be achieved, but the electronics of the instrument must be very good, because a closed loop or force feedback control must be used here. Overall, high strain rate nanoindentation is a challenging field of micromechanics. The main problems are the correct measurement of the applied force, to match sampling rate to the time constant of the electronics, also to choose the right methodology for the material, as well as knowing to processing the data in the optimal way. For further information, please study the paper in the link below.